Thank you all. Today I'm going to bring you on a journey, so strap on in. Before we start, though, I have one word of warning. If you use a memory unsafe language or any language that does not have a strong type system or there is no way to enforce types, this talk will give you very little. Like, it's very hard to apply anything that follows if you don't have a strong type system or your language is memory unsafe. I would also say that if your language is memory unsafe, you probably have bigger problems to solve. So, why am I giving this talk and not someone else? This is not a new concept. It's been known in the industry for at least 10 years, because the first public talk on this subject was given in 2012 by Googler. I've spent some fair amount of time doing security in small companies and big companies alike, and I found something in common, which is they always have the same problems, all of them. And today, I'm going to present you how to solve it. Yes, it is solved, and yes, basically no one is doing it. But hopefully by the end of my talk, you will know how to do that. And if you don't, well, I have a link to the slides at the end, so maybe you can catch up later. So let's define what the problem is. The problem definition that we are going to work with today is just injection related. So has anyone never heard of XSS, SQL injection, or command injection? So you all know at least what these things could potentially lead to. These problems are when part of the program starts executing, and the programmer didn't really put it there. So, and this is a definition that I really like. I came up with it myself, but I'm probably not the first one, to be fair. Any program can be represented as a function from its inputs to its outputs. Any program, it doesn't matter which one. As long as you squint enough, any program looks like this. And no, there is no way any input should ever become part of the program. But this is what happens, and I have a job. Well, I currently don't, but security engineers have a job because this keeps happening. Code injection are everywhere, in every single time that any programming language has to interact with any other programming language. Let's say that you are writing a Go program and you have a SQL query. Let's say that you're writing a Rust program and you need to invoke a bash command or a regular expression. It doesn't really matter. All of these other things are other programming languages. And yes, regular expression is a programming language. I will fight on this hill. So far, what has been proposed is let's just be careful. I don't know about you all, but I like to sleep sound and safe at night. I hate being woken up because something is on fire, especially in my bed. But let's talk about servers right now. One can't possibly be careful enough to solve these problems. Otherwise, things like these shouldn't still be valid. This XKCD, the little Bobby table, exploits of a mom, I think is the title, is a situation in which a mom called their child Robert apostrophe and then some SQL, and accidentally ended up, well, accidentally, kind of intentionally ended up destroying the database of the school. This came out in 2007, which means it was a widely known problem enough quite a while ago. This is still valid today. I've seen stuff like this in production in companies today. I reported it. But by the way, this is the problem we're dealing with. And again, this happens in any situation in which the user can control. You can have the safest language in the world, be it Go, Rust, I don't care. If you do something like that, there is no guarantee that you will write a safe program. Here is a more complicated example. This is important, so we'll spend a little bit of time on it. This is a situation in which we're calling SQL from Go. If you come from Rust Lab, it doesn't matter because this is not about Go. This is about SQL interacting with another language. We're running a query in the first example in the correct way, pass me the term, because we're passing the query as a hard-coded string literal with a question mark in it. That is a placeholder. It tells the SQL engine something is going to go there. And then we pass name, supposedly something that the user gave to the server. Now, the SQL engine will know that name is data. It's not code. Now, if you write that very same semantical thing this second way, you're going to have trouble. Little Bobby Tables is going to destroy your school. So this happens, and there is no way currently in the compiler to prevent you from doing that. So this one, definitely correct. This one, definitely not correct. But what about this last one? In this case, I'm just saying I'm going to run a query, and there is a string variable immediately after. Was the programmer in charge of deciding the content of that variable, or was the user? We don't know. By just looking at this line of code, we don't know if this is safe or not. And this is a problem, because as a person that had to do security reviews, I don't like to chase out where the data flow comes from. So that was the simplest example that I could come up with. Let me show you something that is a bit of a nightmare fuel of mine. This is HTML. I hate it. I want you all to raise your hands if you think that there is only one language on this slide. I mean, except for English. I mean, formal language. What about 2? What about 3? 4? 5? Correct answer is 6, but actually the correct answer is too damn many. Writing an HTML parser is a nightmare, and I maintained 2 for over 2 years. Don't do that. That's a recipe for burnout. Manually dealing with this stuff is not something you want to do. So not just for security, mind you, because if you're writing a web application, you might just decide, OK, any string that I touch, I escape it. I don't care. I encode it as much as I can. But then you end up with web pages that show this kind of stuff. Who here has never seen a web page show escape characters? I bet everybody has seen at least 1% that where it shouldn't have been. So this is not just about security. This is a nightmare to handle just at the application level. But I'm not going to talk about that, just security today. So in order for these to work and be functional, we expect programmers nowadays to be security savvy, never make mistakes, I love this part, and fully understand the data flow of the entire software they're contributing to. Who does that? I mean, never make mistakes, we know, but also understanding the data flow. I used to work at Microsoft and Google. I couldn't possibly keep the entire code base in my head. We had trouble keeping the code base on a server because it was quite large. We had to change the VCS 3 times in 5 years because it was too large. So there is no way you can possibly fathom any of these. So the XKCD that I showed you earlier ended up with the mom telling the school, you should learn to sanitize your inputs. And my argument today is, no, you shouldn't have to. It should be possible for you to write safe code without even knowing what SQL is. So sometimes it's even worse. This is something that is the hardest bit. I will not fully talk about this today. This talk still applies to this concept, but in case you actually have to get some code from the user, but only the safe bits, there are sanitizers, and we can talk about it later. I could not possibly fit everything in 40 minutes. But just rest assured that this concept also applies if you have like a web mail client. Emails are formatted in HTML. So you have to render HTML in an HTML page, which is the web clients, let's say Gmail, ProtonMail, but only the HTML that is not going to execute code in that page. And this sounds hard. It's actually harder. So I'm not going to talk too much about these, but this is also something that this approach can handle. So far, I've probably confused you, scared you, and that was my objective. Welcome to my life. Let's talk now about solutions. There are many solutions available. None of these work. So we have tainting. Some researchers invested an insane amount of time, and I admire them for this, to say, OK, let's say that every string that comes from the user, I'm going to taint it. I'm going to mark it as something unsafe. And I'm going to trace the execution of the program with symbolic executions and a lot of advanced stuff that I'm not smart enough to understand, and see where it ends up. So I know that all the strings that the user touched are unsafe. So I can lint some code and see where the injections are. it doesn't work. It's just too complicated, and symbolic execution is too computationally expensive to run it on a code base of like 10,000 lines. And I think that everybody here has at least used a library at least once that was larger than that. Linters are somewhat helpful. They don't fully address the issue. Awareness courses actually damage. There is strong indication that instructing the programmers on what XSS is makes the situation worse, so makes them more prone to introduce XSS, which is fantastic as a result. And then there are the last three things that are actually the ones that work even less, which are hope, penetration tests, and prayers. I would put them together because they're practically useless. I would say hope serves some purpose because at least you sleep well at night, but that's it. Penetration tests are very good at finding problems, full stop. That's it. So let's take one step back. What can we trust? And this is what I'm going to focus on today. We can trust code that has been written by the programmer. This talk is not about insider threats. I trust the programmer to write code. I should also trust the programmer to write strings, hopefully. Because if anyone here has any programmed a graphic card, they know that that is a hard subject. Strings are not all the same. There are some special strings that I really cherish, and those are compile time constants. We can all agree that a string literal that the programmer typed on their keyboard is as trusty as source code. There's no virtual difference. And today I'm going to show you some tricks on how to make sure that you're always able to tell which string is which. My objective is to bring you to a point where if your code compiles, you know it's safe. This is my objective today. So let's take a look at 4 languages of choice: Rust, Go, TypeScript, and which is TypeScript when JavaScript is involved. Well, it's true, it's a language. So this is the simplest snippet of Rust that I could come up with that gives you this guarantee. You can call this constfn with a literal. You cannot call it with a variable. So this line compiles, this line does not. Even if s is a valid string, any kind of string, doesn't matter. The first one compiles, the second does not. So this gives you a small gadget. And this is important because this is the only thing that you need, really. This gives you a small gadget to guarantee that this function, that you can implement a function that can only be called with a string literal. Go is a bit finicky with its macros because it doesn't have them. So we came up with this neat little trick. So this is a package that contains, package definition, one type definition, and one function definition. Mind you that this type definition is lowercase. So there is no one outside of this package that can construct that type. So I'm trying to protect programmers from accidental mistakes, OK? Again, not insider threats here. But again, we will see that there are bypasses to all of this approach if the programmer really wants to do things. But again, at this point, might as well just write malicious code. So yeah, this function can be called outside of this package just with string literals, because string literals for the compilers will be automatically replaced. So they are a kind string, not of a type string. And string kind implements any string type. So these compiles, this does not. And this is useful. Let's talk about TypeScript. I'm a big fan of the language, by the way, because it made it almost bearable to write web applications. So this is a simple definition. We say, I only accept a template string array. And the only way to invoke a function that has that signature is with the backticks signature. So this compiles, and it calls that function with something as an argument, sort of. This one does not compile. So again, the same gadget. But what if JavaScript is involved? Let's have some fun. So types are not trustworthy anymore, but there are some ways to make sure that unless the programmer really, really tried to screw with you, this was called correctly. Because calling a function with a backtick signature adds some attributes to that signature, to that string. So these checks are to make sure that the function was called as TypeScript would intend. The please stop is because there are other checks, but I couldn't be bothered. OK, now we are weaponized. We have the one gadget that we need to guarantee one thing. We can implement a function that can only be called safely. And by safely, I mean with strings that were in the code at compile time. So code, at least for my definition. At this point, we might create arithmetics on these types. Let's say that we create a type safe string. Concatenated string is kind of useful. So, for example, to compose a query, to create an HTML template. So we could create the operation, we could create the method concat on that type and allow programmers to concatenate strings that we know to be safe. Again, concatenation is safe, two safe strings are safe, so the result should be safe. Now, we get to the point where if the programmer really wants to screw around this thing, they could create one letter constant for every possible character and compose anything at runtime. But at that point, they should be wondering if it is maybe time to change jobs, because they really hate the company, and there is nothing I can tell about that. This is an example of some code that I wrote in the Go Safe Web project. I basically wrapped the standard library SQL package of Go with 60 lines of code that guaranteed that you can only possibly call any query with a string constant as the first argument and anything as the other argument. So this guarantees that only the first query that I showed you about SQL can be written. There is no other way around this. If you pass a string as the first argument, this doesn't compile. And it took me 60 lines of code. So I didn't even know SQL actually that well. I don't care. I mean, I've worked in companies that don't really use fully SQL, but weird dialects. But I didn't need to. I just needed to guarantee that the only strings that were passed were safe. And I could write it in under 100 lines. Now, it's longer than that because Google forces you to add a 40 lines license on any file that you write, but meh. So at this point, I gave you some tools to guarantee that only safe strings are passed where code should go. But what about the other strings? Well, as I said in the beginning, programs transform inputs to outputs. And a program that doesn't get inputs is usually not too useful, somewhat. So we need to find a way to make it flow through and actually end up with the unsafe strings still handled correctly. Now, there are situations in which we are luckier. For example, SQL. A SQL engine, you can tell it, hey, this is the query, this is a string. You do you, just be sure that this is data, and the SQL engine will take the data and treat it as such. There is no need to additional escaping. HTML is a nightmare. This is the recurring theme of my life. So HTML renderers do not do that. There is no way to actually ask the browser, can you please treat these as data? At least currently. So Go has a couple of packages that do contextual auto-escaping. I will show you in a second what that is. In Rust, there are templates that, for example, do one escape on one kind, but not the full thing. I'm very willing to help anyone who wants to write some Rust to implement these correctly. I don't know Rust, and I would not be able to do this, but I'm very happy to help driving this project, because I think that this holds always true. Escaping requires to know the right context. You cannot possibly just escape HTML without knowing what you are escaping for. If you have an injection into a string, into a script tag, that is JavaScript. And HTML. If you have an injection inside an SVG, that's XML. And whoever thought that putting XML in HTML was a good idea, I would like to have a dinner with them, just to have a chat. But escaping must be done as late as possible, not just because you end up with double escaping sometimes and ugly-looking pages, but because it's unsafe otherwise. Writing an escaper is hard. So let's say that you have this template. I use the double mastitch syntax. I think everybody can understand what that does. let's say that I have an image tag with user input there, and the attacker provides these as a string. Any escaper that does not know what they're doing, so any HTML template, also by the way, is not just Rust, any template that is not in the standard library for Go also does this. Like quick template does that very same thing, which is, it encodes it as HTML because the file you're encoding is HTML. But the browser doesn't care. When the browser gets to that point, it's going to unencode the quotes and run the JavaScript because that's its job. That string ended up in a JavaScript context, and the JavaScript runtime has no idea that this comes from HTML at all. So just escaping once is useless. So for a whole of this approach to work, you don't just need safe strings, but also something at the very last step that will take the untrusted strings and treat them properly. The problem is that this is very expensive to write. Like, I think that the HTML template package is above 10,000 lines of code because it contains an HTML parser. Writing an HTML parser is something you shouldn't be doing. And if you do, you should be the only one in your language that does that, because there should be one parser, and everybody should agree that that's the one. And also, sometimes the HTML parser that you wrote does not agree with the browser on what the HTML should look like. So you should be more restrictive than the browser, because browsers are very lousy in what they accept. Like, unbalanced HTML is valid for a browser, it shouldn't be for you. So there are decisions to be made here, and we all should agree on what these decisions should look like. And we should all contribute to the one implementation, because this is expensive again, and as a community, we cannot possibly afford to have 2 of these running around. Right, Google? Sorry, give me a second. So I'll give you a short recap. So we got to this point where we have a way to mark all compile time constants as safe. We can now write functions that can only be called in a safe way, and as long as we have good last step renderers, we are good to go. Like for SQL, we are good to go. For Bash, we are good to go. For HTML, we should stop using it, but we can't, so But this is what we do, and this is how we fix it. Now, most talks and documentation that I've seen on this topic stop here. Now, would you like to raise your hands if you feel confident you would be able to apply this in your company with just this knowledge? Lovely. So unless you knew this already, it's almost impossible to apply any of these in real life. So I decided to add one last chapter, which is how to use it. Because I just gave you a bazooka, and I told you there is an ant hill there. Would you like to take care of that? And shooting yourself in the foot with these is very easy, especially with a blast radius. Now, a lot of people that I pitched this to told me that this sounds like it's going to be very hard to adopt, and actually it's super easy, barely an inconvenience. Trust me, you just need to know what the tricks are. So, for new code, if you're writing a project from scratch, use the wrappers from scratch. So the safe SQL package that I wrote, please don't use that one. But you feel free to just copy it, use it. It's 60 lines of code. It's never going to change. It requires no maintenance because it guarantees one invariant, and that is going to be true forever. So if you're using command execution, a SQL, Mongo, it doesn't matter. Just write your wrapper, use that forever. And have a linter that forbids anyone from importing the raw package. So the only package that imports SQL should be safe SQL. That's it. You're done. New code is easy. For all code, there are a bit of steps that we need to go through. The first one is we promote existing uses as safe. I will get to this. Then we force new code to be safe, and then we refactor the old code to also be safe. I would like to highlight that this is not like the big tech guy approach that, of sorts like, yeah, anybody can do this, just fire up your editor, refactor a bajillion lines of code in 1 second, send one change list that updates your entire code base. No one can do that. I mean, maybe Google or Facebook, but no one has that kind of power. So let's tune it down a bit and let's make it usable. New code, we wrote stuff for Go. I think any language that exposes enough internals for the compiler would be able to provide the tools to write a linter that forbids a package. Like, forbidding an import shouldn't be too hard in any language with a decent linter. Those tools should run locally. Like, don't make the mistake of having a programmer write like 1,000 lines of code, submitting a PR for review, and then they realize their PR fails in CI/CD because they use the wrong strings throughout. Refactoring at that point would be painful. So the errors should bubble up as early as possible. And when you write those linters, don't just say wrong type, because this is the error that you're going to get, wrong type. Please do not. Like, provide clear documentation to the user on why their code is not compiling and how to use their functions properly. Document it, explain how to migrate, provide the tools, because this is really a refactoring trick that I'm giving you, how to move the problem from runtime to compile time, but the problem stays there. So for old code, it's slightly more interesting, because the first thing that you do is you say, any code that I've written so far is safe. I assume it's safe. And someone might raise their hands and say, but we had an XSS last month. And I'm like, still safe. What about the SQL injection that we had? Still safe. I don't care. I assume that everything that has worked so far is safe. And the very reason we do this is because you never want security to hinder productivity. The moment that security gets in the way, programmers, and I identify as one, will get around it. They will find a way to find exceptions and to not write safe code. So let's just promote anything that has existed so far to safe. And it's fine, because it does work. It's been there for a while, so let's just assume that's safe. And then we ban anyone from writing new code that is unsafe. So from this moment on, we have the guarantee that all new code will need to use the new API and the safe API. At this point, you need to have some tools that give you some sort of atomicity, as in, if your company has 21 repos, let's say, you need to be able to roll out this change quick enough so that then you can ban the old API without anyone having used it in the meantime. So let's say you choose the first repo, promote everything as safe, and then you ban the use of unsafe in that repo specifically. And then you move on to the next one. In a matter of, I don't know, a couple of weeks, it really depends, you should be able to have done this migration, because this is also doable with automatic rewriters of code, like GoGrep, I think is called, or GoFix can be programmed to do this in Go. I bet there are at least 17 tools to do that in any other language. Like, code rewriting should be trivial. There is no logic in this. This is just a dumb promotion to safe. And then you fix it. And then you go back and find the old code, find why did you need to promote a string to a safe string in that specific point. And you can also divide and conquer, as in you can tell every team in your company to fix one of the legacy conversions per month. You don't care how long this is going to take, because you were unsafe before. You are just going to be safer and safer from now on. In Google, I had to do one migration that lasted 4.5 years in one project. It doesn't matter, because I knew that every week that project would become safer. So you set the direction right, and you don't want to step on the foots on the programmers that are working on the project. Also, fixing one of these usually required 20 minutes. It's just that we had 16,000 of those. So you don't also want to do this the entire time. Like, don't spend 3 months crunching and fixing these kind of violations, because you're going to burn out, and please do not. If you are in this room, you probably care about security. We need all of you to be mentally healthy. We are very few. So, to distinguish what was an old conversion to a new conversion and all of these things, we use different names. So, in the safe HTML package for Go, there is this function, legacy risky assume HTML. Takes a string, returns a safe HTML. The name is quite telling. So you fill up your entire code base with these, it's fine, you know that those are problems. But at least while doing this refactor, you immediately know what the problems are, because you change the API, you see what doesn't compile, those are the problems. Now you change the names, now those are problems for security, not for the compiler anymore, but the security team or whoever cares about security has a way to grep and find where the issues are. At this point, I would also like to introduce some other friends. Test conversions. No one likes to write safe HTML injection-free tests or like SQL injection-free tests, because usually tests need to like compose queries and stuff. So there should be a package that can only be imported in tests that promote anything to anything. We don't care, it's tests. If you have an infrastructure that allows someone to inject code in your tests, that's the problem. Fix that first. And then there are some situations in which you might need an actual exception. So I was writing a SQL interpreter. The user provided the SQL. I executed it. There is no way around this. This is an exception. And I needed someone to do a security review on that. Any use of the unchecked conversions requires a security review. Any other one doesn't. So this is already taking a lot of weight off your security team or your security savvy expert, local security, I don't know, person. I don't envy them. But whatever. At this point, you're already taking a lot of weight off your security team, so you can dedicate their full effort into writing the secure wrappers, which aren't too hard. I think any people that, even if they don't have security background, can write those wrappers, and I have examples in the links in these slides. But also, yeah, the security team can now focus on the important stuff, like the sanitizer. The sanitizer takes untrusted inputs. You remember the email that you need to format with some markup? Takes untrusted inputs and gives you some trusted input that still is code. So the security team can focus on that. At Google, we managed to be 200 people doing web security for a company that has, cannot say the full figure, but let's say 6 digits employees, and we could stay afloat. With this approach, 200 people could do the security for many more people because we could only focus on these bits. So this is fine, this is okay. Also, you don't need more than one sanitizer per language. And if you do, stop. Just do one. And the raw strings go in the engine or template, whatever. So this is where we got at. Programmers are guaranteed to write code that if it compiles, it's safe. There is no additional effort, no additional overhaul to change this. If a refactor to switch to this model is hard, it means you have XSS or SQL injection. Like, if you find it very struggling to switch to this approach, you're probably removing vulnerabilities as you're doing the refactor. This is how this works. Then you get to a point where the code compiles, and you have no legacy conversions anymore, and your code is safe, but the work that you put in would be the work that a security-savvy person would have put in to refactor your code. That's it. Advantage is you don't need to know what you're doing. And this is something that I really like, because if it is like 3 a.m. and I'm fixing a bug, I don't want to think like, what am I doing? Just arguing with the compiler. I mean, this room, I would expect it to be full with gophers and rustaceans. We love when the compiler screams at us. This is why we're using those languages. We like strong compilers. So let's use them. I will now briefly add some final notes, because of course, as any engineering rule, there are exceptions and additions and addendums. This is not foolproof, because especially in the browser context, some things are weird. So let's say that you depend on an external library that you import, an external JavaScript library, specifically. You can't refactor other people's code. I mean, you can, but shouldn't spend time there. So there are some ways to protect yourself, even when this approach fails. This is especially true for foreign function invocation. So let's say that from Rust, you import a C library, or like from Go, you import a Rust library. It doesn't matter. When you switch language, you basically are giving up the entire type system. So if from TypeScript you import, I don't know, drawing.js, whatever that does, I'm sure that exists, you know that you are up for trouble. So there are some things that you can do, even at a database level. Make sure that you only run the queries with the lowest possible privilege, and that rows are fine-grained when it comes to access. But these do not replace this approach, and vice versa. So use both. CSPs should be used as a safety net, not a security mechanism. And CSP is a nightmare. I gave a talk on that, in case you're wondering. Content security policy. Basically, is a semantic layer on top of HTML that allows you to say which scripts should be executable and which scripts should not. What it actually ended up doing is something that gives you a couple of weeks of work, and then you end up with something that is exactly as secure as before. I have links on how to properly do that. Don't forget UX. Security only works if it doesn't get in the way of the user. I'm going to tell you a little story now. I was doing security consultancy. I went to a company that had a password policy of changing the password every month. And I was like, that's a lot of passwords. I wonder how they come up with. So the first question that I asked was like, what's your password manager? Because not all password managers are safe. And they're like, the password what now? And I was like, sorry, just, out of curiosity, what's your password? Oh, it's December 2016. Just out of curiosity, is the next password going to be January 2017? And they were like, yes, why? Let's say that that's not a password, that's kind of a calendar. So if security gets too hard to do, people will not do it. So you are better off making this simple and not approach every problem rather than not doing it at all or doing it too hard. I already talked a bit about the benefits. There is this XKCD that I love in which a guy says, well, there is a bug, but it's a normal one this time, I swear. Okay, what's the bug? Well, the server crashes if a user's password is a resolvable URL. And the other one replies, okay, I'll get the lighter fluid, let's burn it to the ground. You laugh, but I've seen stuff like this happen. If you use the safe string approach, the strings are going to stay strings, because those strings are hidden inside an opaque type. So you know that the only usages of those are somewhere where it really is needed. They're not going to be confused for other things. Keep in mind that adopting things late is still possible. If you have a 20,000 lines project, still doable. Harder than with a new one, I'm not going to lie to you, but still doable. When it comes to adoption, and this is important, if I were selling you something like some sort of a novel approach, you would say, yeah, sure, but if no one has done this so far, why should we start? What I'm telling you is that big companies do this all the time. It's just not a known approach, but is a well-known approach inside the field. So Angular does this. If you use Angular, you're done. React, it's finicky with the URLs, but except for that, still does a good job at doing this. Go Safe HTML provide this. There is a Python security manager that does this. Yes, Python is loosely typed. And this still works. As long as you can express some sort of types, in this case Python 3, you can still work with it. Ruby has some magic in how it handles string, and the Ruby safe active records does that magic correctly. Reading the source code of that made me realize that I don't want to touch Ruby with a 10-foot pole. And other templates that people use. I can safely say that Google, with the products that were built with this approach, never had a SQL injection, ever. So this works. It's just a matter of using it. And keep in mind something that my grandma always said, which is piuttosto che niente le piuttosto, which roughly translates to doing something, anything is better than nothing. So let's say that you partially migrate and you keep the legacy conversions forever. Keep them. At least the new code is going to be safe. Who cares? It cost you, I don't know, 1 week of changing the API to the new one, and the new code is going to be as expensive to write as it would be otherwise. It's fine. I'm not going to go to your house and tell you, hey, fix those legacy conversions yet? Who cares? It's still good. Now, I could conclude the talk now, again, but I have some beefs with some things. So let me rant for 10 seconds. Regular expressions are a nightmare. Stop using them. Unless, if you know at compile time what the regular expression is going to be, write code. Okay? Who in this room can look at this and tell me what it does? This is a value Ruby regular expression, by the way. You know what it does?
I think so. I need to read it for a while, but I can.
Okay.
The first one is a negative look ahead.
Yeah, right. And then
the number 1. I mean, there's x, and then x more than 1x. there's the number one is the first.
There is a back reference, yeah.
Yeah,
Kind of complicated, right?
yeah.
If this was written in code, you would all be able to read it. This only accepts prime numbers. Okay? It took me 3 hours to write it, but please don't ask. But yes, this this expression only accepts prime numbers of x. Do you want to deal with this really? Because Cloudflare went down once for a regular expression. Stop doing that. Write code, please. And also, there are parsers. All of this talk assumes that you have good parsers for your formats. Use the good ones, not the fast ones. The fast HTTP package in Go accepts that as a valid HTTP request. That's not a valid HTTP. That's barely a string. So when you use something that is quick, you're sacrificing something, because if it was that easy to build something quick, that would be what was done in the first place. In engineering, nothing comes for free. If you switch to quick, you might be unsafe. If you switch to quick, you might have sacrificed something that maybe you didn't know. And rarely those packages document those assumptions. So keep it in mind. And also, don't copy-paste from Stack Overflow security code. Please, stop. When I was at Microsoft, half of the vulnerabilities that we found, I could find the source code on Stack Overflow. And God knows how many other companies copy-pasted the code and had a vulnerability because of that. So write your code, it's better. And also, when you have something like autopilot that auto-suggests stuff from other repositories. So yeah, that was it. That was the talk. Thank you.
Hey, okay, time for a question if you okay.
Oh,
yes.
we have a question.
Sorry.
Nice. Also, if any of you thinks that their company could benefit from this, I also do consultancy. This is not a sales speech, but if you need, why not?
Thank you very much for the talk. It was very interesting and very entertaining as well. Got a question about motivation to actually go through the transition, because that's the difficult part quite often in persuading that this needs to be done. If you have a system that has a little bit of control over its input, say it's integrating with another trustworthy system, how would you pitch the motivation for actually going through the refactoring of maybe the entire code base?
Very nice question. So there are 2 answers to that. If the code you're talking to really is trustworthy, you could say that when you unmarshal those strings that come from that, let's say, other microservice, you unmarshal them as safe strings. So if you have a microservice architecture and things talk to each other and you control all of them, a safe string should be serialized as such and deserialized as a safe string. So this is something that you should do. If there is only partial trust in the other system, you should assume that is no trust. This is a very strict approach, and it only works if there are no lousy assumptions. So the pitch to say, hey, we still need to do this, is that unless you have 100% trust, it should be 0 trust. This is how security works. It works in Boolean. You can't be 98% sure there is no injection, because an attacker, a motivated attacker, will find those 2%. Like, this was my job. I worked as a red team actor for years, and I could always find that 2%. That was what I was paid for. So yeah, if you have a hole, people are going to go through that, not the safe door next to it. So yeah, that's the pitch for security. Pitching security is always hard, though.
Thank you. And I've got another very quick one, probably. You mentioned that awareness courses cause damage.
Yeah.
Why?
Because people felt more confident. This is my conjecture, but people felt more confident in writing code, so they self-indulged into writing riskier code, because they knew that they had the impression that they knew what they were doing, which is interesting because this is like the Dunning-Kruger effect. They knew nothing, but they still thought that they did because they had a course on it. I would not trust myself to write that code. And I have been doing this for, I don't want to think about how many years, but yeah, I wouldn't trust myself to write the code that they did, but they had one course, so they did. There was another question there.
So earlier in the talk, you said something about wanting to help with safe HTML in Rust.
Yeah.
So if there's anybody who wants to do that, Roberto has offered to help with making it correct. And so if anybody is doing a Roberto-approved safe HTML thing, maybe I can help with the problem of only having one parser by lending it additional, let's say, legitimacy by putting it under, say, the Tokyo or the Rust lang name.
Mm-hmm. Nice.
So talk to me if you need help with that.
Okay, thanks. Okay. There is one more question here in front. I told the organizers that I was expecting no questions because I was expecting anyone to be alienated by now, so I'm very happy right now.
So you showed this nice wrapper, but I'm wondering, shouldn't it be in the library itself, like the SQL library? Shouldn't it just offer the safe options so that the developer doesn't need to remember, oh, there's a safe wrapper, but just directly...
Yeah, shouldn't it? Right?
Yeah.
Right? Shouldn't it? This was not staged. But no, yeah, I agree. I opened several issues on the issue tracker for Go, for example, to import these in the standard library because there is the safe HTML package and the safe SQL package. They were all rejected because it would break the API.
So, but if we ever break the API, let's use the safe approach.
If we break the API, we should probably switch to a safer approach. Keep in mind that, for example, the safe HTML package in the standard library provides the functions that promote an unsafe string to safe, because it has to. Like, sooner or later, someone will need to use those promotions because it doesn't work otherwise. And I've seen people do that all the time. So it's not just about providing a safe API, but also explain how to use it.
So maybe a first step would be to add it to the official documentation of the of the library documentation.
Yeah,
SQL,
those functions.
SQL wrapper.
Oh.
Just so that people are. So I didn't know about it. It's
Oh,
very
no one
nice.
does.
So
Yeah.
but I've been to the documentation of the HTML and SQL package, of course. And if there would be like the example would use the safe wrapper, I would have used it because everyone starts with the example on documentation, and so maybe this would be a good thing.
So
to
basically,
get more known.
Okay. So basically, the question is, if there are safer options, I understand that the guarantee should be kept for the old API, but what about suggesting a new API for people that can?
I mean, as
And
I
my
said,
answer-
for new projects, it should just be the default,
Right.
and so the example should be just use the safe.
My answer to that is yes. You're
Let's
right.
see if we can get it happen.
We could open some issues pointing to the safe packages. Also because that safe package is under the Google repository. So it's not like any other, it's not under my personal repo.
So, what if we are using a library that it's a composer of SQL queries? We can really just wrap all this library. Is there a way to do it?
What, like, how many functions, like how many exposed methods and functions are on that library?
I think the one that we are using, which is called Goku, has like 50.
Yeah, wrap them.
Okay.
I mean, it's 3 lines per call. Like,
Okay.
you define the signature with a safe string, and underneath you call the original function with just the unwrap for the string underneath. It's 3 lines times 50 methods. You have 150 lines of wrapper.
And what about the types? Because it creates the types, and those types have methods.
It creates types, but at the point you already passed the query, those types are safe. Like,
Okay.
the only methods that you need to wrap, and this is important actually, sorry. Thanks for asking that. The only methods that you need to wrap are the ones that take strings or integers for what it is. Like, the only ones that you need to wrap are the constructor for the things. Once you get an object out of it, use that object. Unless that itself takes more strings, in which case you have to wrap that too. But some methods will be passed through, which in Go is nice because you can just embed and rewrite the other one or hide it. So basically, you can just touch the things that you need to, everything else can stay as it is.
Okay, perfect.
So for me, wrapping the SQL package, which is about 20 methods, took me an afternoon. So that's more or less the time. Also, I created a snippet in my editor, and I just kept executing the snippet for every method. So that once you're doing that more than 50 times, it's going to be quick.
Okay, thank you very much.
So, prova.
Vai.
Prova. Okay, it works. Talking about regular expression, I was working, say, before at a company where users, companies, our clients could define their own validation, let's say their own payload. You can see it as a JSON schema. And I'm wondering what would be your recommendation, because they could define the validation for their strings with regular expressions, and we cannot generate, maybe we can, I don't know, we cannot generate the code for the user inputted
Correct.
regular expression.
So in that case, your input is the regular expression, not your source code. So it is a different approach of what I talked about. I told people to not use a regular expression in source code. If it is your input, then you should use a regular expression library that never goes into quadratic behaviors, for example. RE2 is one example. The Go standard library for regular expression is another example. If your regular expressions are inputs provided by the user, that is an input for your program, and that is valid, and it's fine. Okay, so you don't need to validate that. Just be careful on where you use them and which library you pass them to. If you use like PCRE, stop. Because PCRE has like one memory corruption vulnerability per day in the Google fuzzer. So
I can't tell you what we were using, but I can tell you that at some point some virtual core were hanging because of regular expressions, so we had to do something for it.
Yeah, in that case, you should have probably just switched library, which usually
We did
supports most of the same syntax. Just, for example, back references in this slide. These wouldn't be accepted by those libraries. Like the Go standard library wouldn't pass that as valid. It shouldn't.
So it looks like we did the good thing.
Yeah. Just at that point, a regular expression is one of your inputs. So it moves to the sanitize as late as possible.
Okay. I guess
Okay.
our time is over,
Yeah.
fortunately. So thank you very much, Roberto Clapis.
Thank you so much.
Thank you so much. Thank you all.